Alright guys, so let's go ahead and get started on the last example here. So we have example 4, and this is our challenge problem. So we have triangle ZOE, and we're asked to find the side OE and measurement of angle measurement of angle O and measurement of angle Z. So let's go ahead and get started on this one here. Since we want to go ahead and find measurement of angle OE, I'm going to go ahead and say that this here is going to be X. Okay. Now earlier, probably want to say 2 lessons before this one, I introduced Pythagorean theorem. So Pythagorean theorem. And what this does here is that it helps you find any side of a right triangle based off 2 other sides that are given. So this is a squared plus b squared equals c squared. And so in this case, I do want to go ahead and identify a, b, and c. Now the c is the side that is opposite to our right angle. So in this case, c would be 9. And for an x, it really doesn't matter which one I choose as my a and my b. The most important one was already labeled, which is c. So let's say this here is a and this here is b. So then we have x squared plus 4 squared equals 9 squared, and all I did here was do substitution. So we have x squared plus 16 equals 81. And since our goal here is to isolate the x, I'm going to go ahead and move the 16 to the other side. And we have x squared equals 65. So from here, since once again our goal is to isolate the x, I'm going to go ahead and do the opposite of a squared, which is taking the square root of both sides. And we have x equals. Now, every time you guys are taking the square root in an equation, you do have 2 answers, which is a positive and a negative. But in this case, we're only using the positive one. So then our answer for this would be either positive square root of 65, or if we do an approximation here, and I do square root of 65, we get 8.06 if we round to 2 decimal places. So 8.06. Okay. So in this case, measurement of angle O is approximately 8.06. So in this case, I would say, I'm sorry, it's not measurement of angle O. This would be side OE. There you go. OE. So this would be 8.06, or it could also be square root of 65 if you want something that's more exact. So we already found one of them. Now I want to go ahead and move on to finding the measurement of angle O. So we have measurement of angle O. And in order to do this, I want to go ahead and find or label what my opposite, adjacent, and hypotenuse are based on my sides here. So then the side that is opposite to our given angle is considered the opposite. And I'll go ahead and just put that OPP. And then the side that is opposite to the 90-degree angle is considered the hypotenuse. So I'll go ahead and put that as HIP. And then the other side in this case would be considered the adjacent. But I'm not going to go ahead and label that here because I actually want to go ahead and just use the sides that were given, since those numbers are exact. And in this case, my side OE is already rounded, so it's already going to be off. My answer will be off because one of my sides is already rounded. So I'll just go ahead and stay with what I was given. So then in this case, I'm going to go ahead and take out my SOHCAHTOA here. And I want to go ahead and see if it's either sine, cosine, or tangent that uses opposite and hypotenuse. So in this case, it would actually be our sine. So then I can go ahead and say sine of, let's say the angle is t, equals 4/9, as this is the opposite over the hypotenuse. So then from here, if I want to go ahead and leave the t alone, I need to do the opposite of a sine, which is an inverse sine. So inverse sine of 4/9. And I'll go ahead and show that in the calculator. So then we go to function. I could press on the inverse sine, go back to main, and do the a/b to get my fraction. So 4/9. And this here gives me an approximation of 26.39. So and in this case, t is 26.39, or the measurement of angle O is approximately 26.39. So I'm going to go ahead and actually repeat the process for the other angle. So this is 26.39. So then t, we're looking now for z. So measurement of angle z. So measurement of angle z. And in order to do this here, now we're basing it off this one here. So if I look at the side opposite to that, it's going to be the side x. Now I had said that I actually don't want to go ahead and use that side. So I'm going to go ahead and focus then on the other side. So this we said was opposite. So then in this case now ZE is going to be considered the adjacent. So I'll go ahead and cross this out and put adjacent. And the hypotenuse stays the same. So now I want to go ahead and base it off this one and this one here. So then in this case, I want to go ahead and see if it's either sine, cosine, or tangent that uses adjacent over hypotenuse. And then in this case, it would be cosine. So then I have cosine. And let's go ahead and make that r equals my adjacent, which is 4, over the hypotenuse, which is 9. So then if I want to go ahead and find r as our angle, I need to take the inverse of cosine. So cosine inverse of 4/9. So we're doing the same thing here. We're inputting this into the calculator, and we have function cosine of 4/9. And notice that although they use the same fraction, it does give us different values because it's sine and cosine. So in this case, r, or the measurement of angle z, is going to be 63.61. So measurement of angle z is approximately 63.61.